I'd now like to introduce Dr. Kevin Lynch from NUIG. So Kevin, if you want to share your screen, you can fire ahead there. Thanks a million.
Okay. Share screen. You see that okay?
Yes, we can. It's perfect.
Thanks. So just first to say that myself and Caroline weren't talking before this. I just see her final point is nearly the same as my final point, so we'll see that a bit later on. My presentation really is about, it was developed just to maybe explain a bit about what's the science behind nature-based solutions on the coast. So I try and do that in a, you know, quite a straightforward way and within 15 minutes. So I have some other bits and pieces in there, but that's essentially the core of what the talk is about. So Emer mentioned already and defined what nature-based solutions are. Really the core of them is this working with natural processes. And when all is said and done, you know, you're looking at sustainable development because you're looking at the social, economic and environmental benefits. But when all is said and done, if there isn't some real component of increasing the value, the status of biodiversity and ecosystem services, then you're probably not talking about nature-based solutions. So that's a very important point to remember. I having a conversation with somebody last week and they were explaining something that was a nature-based solution according to them. And the simple question was, yeah, okay, well, where is the nature in it? Where is the biodiversity? Where are the habitats? So there has to be some component of that in there. And another point to make is that nature-based solutions aren't new. These are ideas that have been around for a while, and they're really an umbrella for ecosystem-based approaches. So as Caroline just mentioned, the climate emergency now has really brought it into focus again around nature-based solutions. But we've seen it before in things like ICZM and marine spatial planning and restoration over the years since the 60s and 70s, when it became clear that we can't survive on this planet without looking after nature. So just a good touchstone for if you want to read a bit more about it is this particular document that's just been published, and the website link is there as well, but it's the EU document on nature-based solutions. So that's just to start off with. So really what I'm talking about today is coastal ecosystems and coastal nature-based solutions. And the seminal paper on this was published in 2013. So, you know, we're talking nearly 10 years ago. And that was a point that led up to all the ideas being put together in one paper. So this paper from Nature from 2013 is where I've gotten some of these diagrams and that I'm going to explain. So there's really two kind of scenarios that I'm going to look at. One is this first one where you're talking about this top line here, where we're looking at conventional and ecosystem-based coastal defenses around an urban city where you have maybe wetlands in the past or whatever. And then the other one is a soft coast where you have dune systems, beach and dune systems. So I'll look at each of them in turn. So the first one here, this top left one, just to kind of explain, you know, what are the conventional approaches that have been used for the last, say, 50 years since World War II, when we kind of went off on this idea that we can control nature and we have all the solutions, and engineering and humans can come up with every solution to every problem we have. So what has happened in that time in terms of coastal flooding and coastal erosion is we've built up areas with large coastal defenses. So this is an aerial view of a sorry, this the other screen is blocking what I'm looking at. This is an aerial view of what a urban area might look like. So these pink parts are urban areas. Here's an urban area here, another one here, and maybe some suburbs in between. In order to protect against storm surge, coastal flooding, these lines here represent sea walls. So you have sea walls built up along here and in different areas to protect against the flooding. And some of the impacts of these are that because you're disconnecting the land, and in this case here, a wetland, from storm surges, in the bottom part here, you get degradation. So a wetland needs flooding to operate function as a wetland. And if that's cut off, then you're going to get wetland degradation here. In these areas up here, you have, because the area is protected and you have urban areas building up, you have greater water extraction from the surrounding areas. So you might get land subsidence. So the land is actually sinking. And if you think about sea level and sea level rise then, and relative sea level rise, if you have a sinking, a land mass that's sinking, that's just exacerbating the problem of sea level rise. So that's another effect of this. But the main effect that I wanted to show you here is the peak in the storm surge from an approaching storm. So if we add in here, so you're looking from above, and you have a storm approaching here from the west, and you're looking at, these are the wave crests of the storm as it approaches. As it comes into this channel or this small bay, the storm crests here approach the bay, and as they move in along the channel becomes narrower as you move inland. And so what happens is the crest of the wave, the length of the wave, gets confined more and more as you move in the channel. And you get to the point here where it's really well confined. And the result is that the water has to go somewhere, so it moves up. And so your storm surge level actually increases as you move in the channel, so that when you get to the urban area that you're trying to protect, not only do you have land subsidence over time, long periods of time, but you also have this increased storm surge that reaches the urban area. So it's actually quite counterproductive. You're trying to protect against flooding, but you're actually increasing the likelihood of it. And this is, in some cases, you will hear, oh, you know, this hasn't happened in our lifetime. We've never seen this. This is something that's unprecedented. Well, the reason for that oftentimes, and not just in this scenario, but right across the country, you hear it in rural areas as well. It's because the land surface and our land use has changed. The way in which the natural processes operate have changed over time. And so there's just no precedent for these events. Okay, so that's what happens to storm surge in this scenario. So if we look at it in, if we had an ecosystem-based coastal defense and went back to a more nature-based solution, we're looking at this top right-hand corner here. So what we have here is a restoration of, well, the first thing is you remove some of the coastal defenses, and this has been tried in many places around the world and has been shown to be effective. And here you have all the coastal defenses completely removed, and then you have some restoration of coastal wetlands or creation of coastal wetlands in these areas. So what happens then is, if you have a storm surge, again, the same storm surge moving in here, and rather than it being confined to a channel, what actually happens is that the crest of the wave leaks out along the wave crest, and the wave moves into these areas of wetland and across the wetland. So the volume of water moving up the channel is reduced. So here's your storm surge at this point has been much reduced from what it was originally. And then you get all the way into this point at the city that you're trying to protect, and the storm surge is practically negligible at this point. So you have water also moving into the wetland areas and recharging the wetlands. And in some cases then, Caroline mentioned about urban areas, the same idea in urban areas where you create green areas here, and you're essentially slowing the flow. You're creating places that water can go that isn't, you know, urban areas or people's houses you're trying to protect. that's what happens in this sort of scenario. And of course, you need space for wetland creation or to restore former wetlands. It's not, you can just create them anywhere. Other things just to note in this particular scenario is the introduction of reefs here, and these are natural reefs. And the idea here is that you slow the speed of the wave as it crosses. You take the energy out of the wave. And then this would be very important for reducing things like coastal erosion. Coastal erosion is caused by the energy of the wave. So if you take the energy out, then you're reducing the likelihood of erosion. Sorry, I just wanted to show that this process here in a photograph. So this obviously isn't a wetland, but as the wave crests are coming past this point here, there's an area that the waves can leak in here. It's a harbor in this case, and you can see that they're elongating out here. And so by the time you get in here, the wave crests are a lot smaller. The wave energy is a lot smaller than it had been in here. Okay, so just to go back to this idea of introducing reefs. So the reefs themselves or the wetland, both of these can reduce the wave energy. And this is just a few pictures of what these look like. So here you have salt marshes. Here's a salt marsh in Mulranny. These are oyster trestles here. Here's a natural oyster reef. And any wetlands at all that that are natural to an area and can be restored can work. These are seagrasses here on the right-hand side. We have these out in Galway Bay along by Salt Hill, especially. I've seen them. And these are kelp forests. These are also really good at reducing wave energy. And here's some kelp that has been restored in plots, specifically as a nature-based solution. So just how does that happen? These are just a couple of more examples. These are mangroves. Obviously, these don't apply to Galway, but it's the same idea. You have wave height being reduced as it reaches the coast. These are seagrasses, and this is corals and coral reefs. So how does it work? So if you have a wave approaching from this direction here, this is an oyster bed, and this is a restored one. This is a badly degraded or eroded one. In some cases, they might be completely absent at this stage, taken out from either harvesting or over harvesting, or to create just to remove them so that you have channels for navigation for yachts and whatever else the case may be. So if you have a storm approaching from this direction, as the storm passes over this degraded or dead oyster bed, this is the wave energy here. So the further you go down in the water column, the less the energy. But you can see that the profile of energy across the water column doesn't change at all once it passes over this reef. And so what you have then is a lot of energy still approaching the coast here. The possibility is then that it can erode sediments along the coast and move those offshore. And you have your sea level, your water level here, right up against the building that you're trying to protect. So in this scenario where you restore a type of a reef, or any of the reefs that I've just shown you there, or any of the habitats, here again you have the wave energy as it crosses here. You can see that the arrows, the length of the arrows are what you're looking at here. You have much reduced velocities after it has passed over here. So the drag created by this feature, by this habitat, is taking energy out of the wave. So you have much reduced energy here. Then if you again pass this over something like kelp or seagrass, it's much reduced again. And then rather than eroding the coast, the waves that move up into this shoreline area are actually moving sand landward at this stage. Even during a storm, this can happen. And so you get buildup of sediment along the coast, and then this acts as a natural barrier to coastal erosion and flooding. So compare this to this. So that's these are examples for a broader bay, a bigger system. And there are lots of examples around the world of for these types of solutions. The living coastlines on the east coast of the US, oysters and oyster reefs are a common one, and salt marshes. So there's a huge database there of evidence on that one, and case studies. The Pathfinder series that was done across Europe, there's lots of good examples in that. There's, in particular, there's a few of them in the UK with very, very similar contexts to Galway and Galway Bay. Before those two, there were a whole series of ICZM demonstration projects across Europe, and many of these have nature-based solutions as a component as well. New York City is a very good example where you think, oh, this is a seriously urban environment that you couldn't possibly have nature-based solutions. But they have a 1 billion oyster project going on at the moment, looking at restoring oyster beds right across the bay in front of New York as a coastal protection measure. And on the side then, they also are trying to restore as many of the wetlands so that the storm surges can leak off into those wetlands before it actually approaches the city. And of course, there's many examples in that document, the EU document. And I'm not sure if it was more a question mark, if Natural Capital Ireland have a database or are planning on putting together a resource as well. So maybe we could talk about that afterwards. In terms of dunes then, the standard way we have approached dunes, coastal dunes and beaches and cities are to build seawalls and put in groins. You'll see in this particular diagram here, there's no barrier here to storm waves reaching the coast. So you have these massive waves crashing right on the coast. Groins, they look like this. They prevent sand moving along the coast, or that's the idea. This is just an example from Salt Hill of some groins. So they prevent sand moving this direction. And then we should all know what seawalls look like. They prevent water moving across shore. So here's an example of one that's built between the sand dune and the beach. And here are just some other examples from around the world. Usually not particularly nice looking features. Although a lot of people in Salt Hill would give you an argument on that, they like walking on. So what are the problems with some of these? They change the hydrodynamics. So if you put in a seawall or a hard structure, it essentially moves the energy down the coast. And so you get increased erosion very close to the ends of these, on both ends of these types of structures. So you protect this area, but you increase the likelihood of erosion down the coast. So if you drew a straight line across here somewhere, you would have the original shoreline, and this is rapidly increased because of that protection. And then directly in front of it, and you see this right across Ireland in most of our coastal villages and towns where seawalls have been built, Lynch is just one example. You have the wave energy coming in, crashing off the wall. It has to go somewhere, so it usually returns to sea during a storm along the seabed. And because there's so much energy there, it takes away the sand with it. And so you get a lowering of beaches in front of these seawalls and a loss of beaches at high tide. So when the tide comes in, your beach is actually gone. So you've completely lost your beach at high tide. And the comparison then between that and a nature-based solution, the first thing you can see without the seawall here and the engineered structures is that the whole size of a natural barrier is wider. And we call it a barrier because it's literally a barrier to energy and flooding from the sea. So that's the first thing we could say. And then the other thing is that the connection between the sand on the beach and the near shore and the coastal dunes, it's possible for sand to move between these and along shore. So these arrows are all indicating that you can have sand movement between them. So here's just one example from that. Here's a beach up in Derry on the north coast, a nice healthy wide beach, embryo dunes, big a dune system that has been there for maybe 100 years, and it all erodes in one storm. over the winter. So you have about 4 meters vertical erosion, and then the beach itself is completely lowered. But in the following year, the following summer, a lot of this sand has just come back on shore. It's been offshore, has been moved back on shore. And so that connection between the beach, the near shore, and the dune is still there. So the nature-based solution is that these things can fix themselves if left over time. And just in terms of a diagram, how does that look? This is the part that's been eroded. It moves offshore, and then over time, it's moved back onto the beach. But it's this section here that is probably a problem in a lot of cases. This is the part where the dune actually reforms in the position that it was in. And look,
Kevin,
sorry,
Kevin.
Yeah.
Oh yeah, sorry. Can I just give you a 1 minute there, just on the time? Brilliant, thanks a million.
No
Fantastic, brilliant, thank.
Okay, so this is the dune, and over time, it takes time for these plants to come back in place and to grow again. But while you're waiting for that to happen, you can lose your sand through the dune system. So that's it, moving back into the dune system. So although it has come back on shore, it's been lost. And in this case, it can also be lost back offshore again with another storm. And just to show this in context in Salt Hill, this is January 2015. So we had storms, removed all the sand. It came back, although this is March, it actually came back within 2 weeks, it was back. And here's another example there. And this is an example from 2017. What was that hurricane that passed through? So this is before the storm, and this is after the storm. So this sand here has simply moved to the bottom of the beach. This is only 50, 60 meters away, and then that moves back up over time. So in terms of nature-based solutions, what can we do? We can let nature do its thing. So that's the first example, and that's Grattan Beach. We can give nature a helping hand. So some planting and some fences and keeping people off from trampling. And we can also do more structural stuff using things like beach nourishment and more large scale things. And then once you move beyond that, you're not really helping nature very much. So whether it's a nature-based solution or not, it'd be hard to justify. And as Emer mentioned earlier on, ecosystem services, it's not just coastal protection. There are so many other things that you get from this. In terms of examples then, again, there are lots of examples from dunes, but I just wanted to mention that this isn't something new in Ireland. So these are examples of past guidebooks and practices from Ireland that we have that knowledge base already. So we're not trying to learn something new. In terms of Galway Bay, I was just mentioned before I started that particularly for Grattan Beach, we have an idea for a project, and I'm talking to the environment section about that. And just some final thoughts. My final thought here was one of the key things here is that doing this correctly is about engaging communities, and doing proper engagement is about having conversations. So it's not about consultations. It's not about coming up with a plan and then asking the community what they think about it. It's really about talking to communities and co-designing the future, co-designing solutions. So I've further thoughts on that on my blog, and you can go on there to see exactly some of the ideas that I have about that if you get a chance. They're all quite short blogs. And lastly, just to say that the Maharees community is a really good example in County Kerry, where the whole community came together. The image there was 200 in that room. They have lots of people working over the last number of years on trying to save their dune system. And they have done something in the order of, there it is, 350 actions over the 3 years. But the problem with this is it's not sustainable. This is people doing volunteer work, and they need help doing that. So it's a combination of what the councils can do and what the communities can do, and coming together to actually try and come up with that co-designed future in consultate, not in engaging with each other to do that. So I'll leave it at that.